Good day everyone, welcome back to our mathematics series. Today we'll be continuing our discussion on plane mensuration and we'll be discussing the area and perimeter of a triangle. Triangle. Now we have a diagram of a triangle. Now for the very first part, our perimeter is simply the sum of all the sides, which make our perimeter to be equal to A plus B plus C. Now the area of a triangle is given as area is equal to half times the base of the triangle times the height, or abbreviated because area equals to half B times h. Now in right angle triangle ADC in our diagram, sin C is equal to opposite of our hypotenuse, which is equal to h over b. Cross multiplying, it makes h to be equal to b sin C. And the area of ABC is equal to half AH as we have deduced earlier. Now substituting h into the formula, our area becomes half times A times B sin C. When multiplied, becomes area is equal to half AB sin C. Now this formula is used when we are given two sides and the angle of the opposite the third side of the triangle. So when we are given two sides and one angle, we use this formula instead. But when we are given the base and the height, we use our first formula, half base times height. Now we have what is called Aaron's formula. Now Aaron's formula allows us to calculate the area of a triangle when you know the length of all three sides, that's A, B and C, without needing to know the height or any angles. Now Aaron's formula states that area is equal to the square root of s into s minus a into s minus b into s minus c, where s is equal to a plus b plus c divided by 2. Now in triangle, any one of the three sides will be taken as base, while the height is the perpendicular length from the opposite vertex to the base. We have an example from NECO 2009, and it states that calculate the smallest angle of triangle ABC in which line AB is equal to 7 cm, line BC is equal to 12 cm, and line AC is equal to 9 cm. Else or otherwise, find the area of the triangle correct to 2 decimal places. Now for our solution, we represented this in the diagram. We're given the three sides. We are going to be using Aaron's formula. We state that area is equal to the square root of s in bracket s minus a in bracket s minus b and in bracket s minus c, where s is equal to a plus b plus c divided by 2. We are given a to be 7, b to be 9 and c to be 12. Now our first step is to look for s. So s will be equal to 7 plus 9 plus 12 divided by 2, which is equals to 14. Now substituting for s, a, b and c in our formula for area, area will be equal to the square root of 14 into 14 minus 7 into 14 minus 9 into 14 minus 12, which will make area to be equal to the square root of 14 multiplying 7 multiplying 5 and multiplying 2. Multiplying our square root or the value under the square root, our area will be equal to the square root of 980, and when we find the square root of 980, area will be equal to 31.30 centimeter square. We have another question from 2005 NAPTEP, and it states that ABC is a triangle with line BC being 8.4 centimeter, ADC is equal to 90 degrees and the area 40.60 centimeter square. Find AD. And we're given the diagram to represent it. Now for our solution, we know that area is equal to half base times height. We're given the area to be 40.60 centimeter and our base to be 8.4 centimeter. So we are looking for our height, which is AD. Now substituting, it becomes 40.16 is equal to 1 over 2 times 8.4 times AD. Simplifying further by cross multiplying, it becomes 40.16 times 2 is equals to 8.4 times AD. And multiplying both sides becomes 80.32 is equals to 8.4 AD. Now dividing both sides by 8.4, it becomes 80.32 divided by 8.4 is equals to AD, which will make 9.56 centimeter to be equals to AD, and AD is equal to 9.56 centimeter. We have another question from NECO 2011, and it states that calculate the area of an equilateral triangle of side t centimeter, leaving your answer in short form. Now for our solution, equilateral implies all sides are equal and the three angles are equal, that is 60 degrees. Now when you see this in the diagram, we get the diagram as shown on the screen. And using the formula, area is equal to half AB sin C, since we know the value of our side and the angle. So substituting, it becomes area is equal to 1 over 2 times t times sin 60. But recall that sin 60 is equals to 3 over 2. So substituting for sin 60, it becomes area is equals to 1 over 2 t squared times 3 over 2 and multiplying to be equals to 3 over 4 t squared centimeter square, and the correct option is B. We have another example from 2007, and it states that in the diagram, line LM is equals to 4 cm and angle LNM is equals to 90 degrees, and tan Y is equals to 2/3. What is the area of the triangle LMN? And we'll give you the diagram of the triangle and our options. Now for our solution, first we look for line MN using trigonometric ratio. And from the question, tan Y is equals to opposite over adjacent, which is giving us 2/3, which should be equal to 4/mn. That's opposite over adjacent. Now cross multiplying, it becomes 2mn, or 2 line mn is equals to 4 times 3, which will make 2 line mn to be equals to 12, and dividing both sides by 2, line mn will be equals to 6. Now having gotten the value of mn, we can now use our area of a triangle, which is equals to half base times height. Substituting for mn and our height 4, it becomes area is equals to 1/2 times 6 times 4, which will make our area to be equals to 12 centimeters square. Here are some exercises for you to try your hands on at home. And for more insight on this topic, you can check out our Hidden Facts SSC Mathematics textbook. You can get the hard copy in bookshop, or if you are interested in the soft copy, you can get it at the website on the bottom of the screen. Thank you.